liftoff of Space Shuttle Endeavour, preparing our home in space for a larger international family.
Houston now controlling.
Roger, roll, Endeavour.
Commander Chris Ferguson confirming Endeavour is rolling on course for a rendezvous with the International Space Station. 8,000 miles an hour. Altitude 1 mile. Downrange distance 6.5 miles from Kennedy Space Center orbit. Down 72% of the rate of thrust as the shuttle goes through the realm of maximum aerodynamic pressure. Altitude 5 miles, downrange 8 miles from Kennedy Space Center to 1,500 miles an hour.
Endeavour, go and throttle up.
All systems remain go.
Anybody who remembers Challenger remembers that's when that accident occurred. This is a key point when the engines actually thrust to in excess of 100%. I'm not sure how that works, but 104% or so.
109 eventually.
Yeah, 109. So that's like the maximum pressure on the shuttle as it goes up in that constant, right?
Right, that's how we throttle down. They call it throttle buckets. If you look at the thrust profile, it goes down like this. To take the heavy loads, drop them down just a little bit.
And you know what, we're watching very closely as we reach the point where those twin solid rocket boosters will come off, be jettisoned, and go back into the sea. And boy, it was just bright as day here, wasn't it? I felt like I had my sunglasses on. What are you feeling on board the shuttle at this time?
Well, we're just about at 2 minutes. Yeah, so the thrust is starting to tail off on the SRBs, and you can see there's the separation, and you can feel that sudden drop from 2.5 Gs down to just a little bit more than 1 time your normal weight.
Yeah.
And everything gets very smooth.
Booster officer confirms a clean separation of the two solid rockets.
It's almost like a lazy thing with tremendous speed. This is the moment where you breathe a sigh of relief on board, right?
Because the solids are gone.
They're loud, they're rumbly, there's a lot of vibration. All of a sudden you go to a much smoother ride.
And they can't be turned off. So the main engines can be controlled, but the solids, once they light, they're burning until they're done.
Now, what we do have also as well, as we should be seeing shortly, are pictures on board. There you see those twin solid rocket boosters. Almost looks like a couple of cigarettes that have been tossed off of a vehicle on the road or something. As they make their way down, they come down by parachute or fished out of the water and reused, repacked, and there you see what looks like a planet or a star, and that's the Space Shuttle Endeavour on its way.
That's right. And at a night like this, you can see it for a long ways. We can still see it out there behind us.
Yeah.
Just gorgeous. If you're lucky, and it's not cloudy, which today is crystal clear, beautiful day for lunch, we can see it all the way to the horizon. It'll be really amazing.
And at this point, the crew is starting to get the sensation of additional G-forces, more pressure on them. And that steadily builds up. It's right. How that goes.
The shuttle, the thrust from the engines is constant. So as the vehicle gets lighter, the acceleration increases. So when the solid rocket motors dropped, we went down to just a little bit more than 1 time our normal weight. But as we lose weight and burn up propellant, we'll actually get up to 3 times our normal weight. And then the shuttle's only designed for 3 times its normal weight. So we actually throttle the engines back again and hold at 3 Gs for about 30 seconds.
Now, in the post-Columbia era, there's a lot of concern about debris, of course. Did you, in the course of your missions, did you ever notice any things falling on the...
You really can't see it.